First we will deal with the sound pollution, air pollution. So you can see the different primary pollutants here. So we need not remember all of them, but you have to remember these two. H2SO4 is a secondary pollutant. It is more toxic than SO2. And then you have to check the formaldehyde also. You already know the PAN is secondary pollutant, ozone is also secondary pollutant. So these two, formaldehydes and H2SO4, is important. And then the types of fumes, we will see them later. Here we have to see that the gravitational settling chamber, okay, the minimum particle size is 50 micrometer, and the efficiency of removal is also less than 50%. And Venturi scrubbers, also used for gaseous pollutants, the minimum particle size is just 0.5 meter, and the efficiency of removal is less than 99%. It's good, efficiency is good, it's the most efficient. Electrostatic precipitator is also good. And fabric filters. See, controlling air pollution from automobiles. So what are the pollutants which will come out from automobiles? There is carbon monoxide, HC, and NOx. NOx is the most important thing. So it is in the range of 500 to 3000 ppm. So and then see there, with this will what is absorb these pollutants. We will see them later. See here, ambient sound quality. So in residential area, in daytime it is 55 and nighttime it is 45. Okay, fine. See here, what is the difference between mist and fog? Mist means aerosol consisting of any liquid droplets, but fog is which contains only water droplets. And dust, this smoke, it comes from burning of fires. Fumes generally means the same as smoke, but often used to indicate aerosols produced by condensation of hot vapor of metals. And then what is fly ash? Fly ash is finely divided non-combustible particles contained in flux gases arising from combustion of coal. These minerals are metallic oxide are formed when organic part of coal is burnt. So what is a smog? Smog is smoke plus fog. It can be of two types, photochemicals or coal induced. The photochemical smog is caused by the interaction of some hydrocarbons and oxidants under the influence of sunlight, giving rise to dangerous peroxyacetyl nitrate (PAN). Hydrocarbons plus NOx gives rise to smog. So coal induced smog consists of smoke, sulfur compound and fly ash. So and then photochemical action, air pollution. Okay, leave it. So here, nitrogen dioxide photochemical reaction. NO2 in the presence of sunlight gives us NO2 star. NO2 star will disintegrate into NO and O. O reacts with oxygen to give rise to ozone. So this is the thing. Okay. PAN is also formed by NO, and then ozone is also formed by NO. See, generally clean air is slightly acidic as it dissolves varying amounts of carbon dioxide. If pH of rain falls to 5.6 or below, then it is called acid rain. The lowest pH value of rain is 5.6 when it is clean. So an aerosol, suspension of solid particles in air. So you know what is an air mist, what is a fog, what is the dust, smoke, fumes, fly ash, all these things. And then see here, an SO2. SO2, combustion of fuels, especially coals, refineries, chemical factories, incineration, affects acidity in fogs, smokes and rain, corrosion of buildings and metallic objects. CO, highly poisonous, it acts as asphyxiant. So combustion of automobile exhausts, organic material like natural gas, coal and wood are completely burnt. Oxides of nitrogen, NO2, NO, NOx, ozone photochemical smoke. So, atmospheric nitrogen combines with oxygen. Atmospheric nitrogen combines with oxygen at high temperature. So, automobiles incineration, so on asphyxia, respirant discomfort. So, see here again. Out of seven, only nitric oxide and NO2 are considered pollutants. So NO and NO2 are considered pollutants. NOx becomes more significant because they result in the formation of secondary pollution such as ozone. Okay. And then hydrocarbons, fumes from oil refineries, they result in the formation of secondary pollutants like aldehydes and ketones, H2S and mercaptans. The sulfur containing organic compound RSH. Okay. HF, manufacturing of phosphate fertilizer, aluminum industry, brick industry, etc. More harmful to vegetation than humans, which is hydrogen fluoride. This is important. Ozone, it reaches much deeper into the lungs than SO2. So lead, automobiles, carcinogenic vapors, benzopyrene, insecticides, central nervous system abortion. Example DDT. Greenhouse gases. What are the greenhouse gases? CO2 and chlorofluorocarbons and ozone are greenhouse gases, but in addition to them you have to remember these N2O and CH4. So they are also the greenhouse gases. So these two though you are fine. So NO2 and NO are considered as pollutants, right? N2O is a greenhouse gas and CH4 also. When it comes to strength, the CO2 is the least, CFC is the best, and N2O and CH4 that follows. And then what are the sources? CH4, decomposition of organic compounds. N2O, excessive use of nitrogen fertilizers. CFC, fire extinguishers, paints, sprays, etc. Ozone layer depletion. Ozone layer is present in stratosphere 25 to 40 km above ground level. So CFCl3 in the presence of UV rays gives rise to chlorine and other substances. Cl plus ozone gives rise to ClO plus O2. Methane destroys chlorine, and this thus affects the protection of the ozone layer. Similarly, NO2 reacts with chlorine and helps prevent the depletion of ozone layer. When there is no chlorine added in the hydrocarbons, these substances are very important replacement for chlorofluorocarbons because they pose no threat to ozone layer as they do not contain chlorine. When there is no chlorine in the hydrocarbons, these substances are very important replacement for chlorofluorocarbons because they pose no threat to ozone layer as they do not contain chlorine. See here, methane destroys chlorine and affords the protection of the ozone layer. Similarly, NO2 reacts with chlorine and helps prevent the depletion of ozone layer. When there is no chlorine present in the hydrocarbon, these substances are very important replacement for chlorofluorocarbons because they pose no threat to ozone layer. Vienna Convention and Montreal Protocol are said to protect the ozone layer. So Venturi scrubbers. See, when aqueous solutions other than water are like lime, slurry of MnO, MnO2, MgO are used, we achieve removal of gases, pollutants also from fuel gases. Wet scrubbers or Venturi scrubbers. Electrostatic precipitators. So 99% of efficiency. And then control devices, adsorption unit, so it can be activated carbon, silica gel, fuel acid, etc. Combustion unit, catalytic combustion. So for removing SO2, we will use vanadium pentoxide. For removing NOx, we will do platinum metals. For removing hydrocarbons, we use activated alumina, oxides of CO1, CO2, palladium. So SO2, vanadium pentoxide. Why vanadium pentoxide for SO2? And NOx, platinum metals. So you should develop a mnemonic for this, else it is difficult. Then automobile emission, petrol engines, HC and CO, diesel engines, NO, smoke, particulate matter. Proper burning of engine and carburetor helps in control of pollutant emission. Catalytic converters helps in oxidizing CO and HC into CO2. Layers of atmosphere, you see troposphere, stratosphere, mesosphere and thermosphere. Temperature falls with height in troposphere but increases in stratosphere, again falls in ionosphere and increases in thermosphere. See, troposphere, stratosphere, ozone is present. Okay, and troposphere, greenhouse gases. Mesosphere, this is here, absence of greenhouse gases. Troposphere, gases in ionic and trapped insulation. Ionosphere is used for radio communications. Flumes, looping flume, super adiabatic, neutral flume, neutral, coning flume, subadiabatic, fanning flume, extreme inversion, lofting flume, strong super adiabatic above inversion, fumigating flume, inversion above the top slack and super adiabatic below the stack. Trapping means inversion above and below. We will see them. So, looping flume. In this case, the air is in here in super adiabatic condition. That means temperature fall in the material is more rapid than atmosphere, so there is rapid mixing. And then remember, it is super adiabatic phase. Neutral means it will rise upwards. So and then fanning means inversion. See the movement. Coning means it is subadiabatic in nature. So flume dispersion is known as coning because the plume makes a cone like shape above the plume line. Lofting flume, where there exists strong super adiabatic lapse above the surface, so it will loft above, and mixing will be quite turbulent and rapid above the inversion. So and then fumigating. So the super adiabatic phase occurs below the inversion. Trapping, inversion above and below.